What about list with named elements? So what's going to happen when, for example, you have a list? Let's recreate a list. Let me now give names. So I'm going to call 1 because it's going to be the first element. This is still our logical vector true and false. What's going to be the first element? Closing parenthesis, add a comma, and then our second element, I'm going to give it name 2. And this is going to be our numeric sequence 1 to 3. So what if I create this type of list in which the elements have these names 1 and 2? Again, you could give them double quotes or you could unquote them, like in this case. With lists, you could also take advantage of the name, again with single brackets, and specify the name of that element that you want to extract. For example, like this, the first one. Or of course, if you want to get the second one, just type within quotes number or name 2, and that'll give you, in the first case, that'll give you the logical vector with the true and the false. In the second case, it'll give you the numeric vector with 1, 2, 3. Related with named elements, we also have a slightly different notation that I like to call dollar notation. And this is a specific notation for subsetting elements that only applies to lists. And because data frames, it's a special type of list, well, it also applies to data frames. So with the example of our list with named elements using dollar notation, you type the name of the object list, then the dollar sign, that's why I call it the dollar notation, and then the name, either quoted or unquoted, let's say the name 1, to get the logical vector with true and false. Again, outside the blue box, so it's like unboxing. You get to see what it's inside the wagon in the first position. Same thing with list $2. That'll give you, as you can imagine, the vector in the second position, or the vector associated with the name 2. It's going to be our numeric sequence 1, 2, and 3. You could also use this notation for data frames. So going back to our data frame DAT, I could take advantage and use the dollar operator, dollar notation, and for example, refer to column name, or I could do that dollar, refer to column height, and finally that dollar refer to column force. So all of these guys will also work. Important things, you are only allowed to specify a single name. So if you try to do something such as that dollar, and let's say with the combined function, you specify name and force. So if you try to use the dollar operator with some syntax like this, trying to extract the name and the force columns, this will not work. This will give you an error. When using the dollar operator on a data frame, if you use the dollar sign and you specify the name, let's say XYZ, of something that doesn't really exist in that, so this would be a name that doesn't correspond to any columns in that, R will give you, by default, it will give you a null value. A special type of subsetting in R, it's called logical subsetting, and it's so special that it has its own name. Simply put, the main idea is to use a logical vector as the indexing vector. So that's the whole idea. To give you an example, let's consider two vectors. For instance, vector X. Let me take advantage of our previous vector. Now I'm going to add a fifth element. Let's also consider another vector Y. And this guy, it's going to have characters A, B, C, D, and finally E. So we have these two vectors. Let's also consider the possibility that in some sense, somehow, these two guys are related vectors, X and Y. So there is some sort of connection between their elements. And let's see how to do logical subsetting. What is the idea behind logical subsetting? So first, let me start with a command, something such as X greater than 5. So in this case, remember this is a comparison operation. Visually, what's going to happen, we have our 5 elements, 2, 4, 6, 8, and 10. And R will compare 2 is greater than 5 and vectorize that operation. 4 is greater than 5, 6 is greater than 5, 8 is greater than 5, 10 is greater than 5. You get the idea. And then, well, the actual answer will give you true or falses. So 2 greater than 5, this is going to be false. 4 greater than 5, this is false. 6 greater than 5, true, true, true. So the whole output is going to be a logical vector. I'm just going to abbreviate it with false, false, true, true, true. Again, so this is the actual output of this operation. Notice that it is a vector, and more importantly, it's a logical vector. And the idea is to pass that vector for subsetting purposes. So I could take Y, again, the brackets, and then inside Y, do the comparison X greater than 5, closing the bracket. And what R will do is, remember, this is our logical vector. So what we're doing is subsetting logically. So all those positions that match false are going to be excluded. All those positions that match true are going to be part of the output. So let me write here the logical vector. And down here, I'm just going to write the correspondence with the character vector Y, A, B, C, D, E. And again, everything that has false, it's going to be excluded. So A and B were going to be excluded. So the actual output of this command will be C, D, and E. Another example, let me subset X in terms of Y. For instance, I could take my vector Y and ask R which elements in Y are equal to A, for example. So again, the input, the indexing vector, it's a logical vector because I'm doing a comparison. And the output of this operation, again, based on our two vectors, again, just for pictorial purposes, let's consider X and Y here. So we're gonna have their 5 elements, 2, 4, 6, 8, 10, A, B, C, D, E. So the logical comparison has to do with Y, which element corresponds to A. So this is the element that's true. This is going to be false, 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 false. And therefore we exclude 4, 6, and 8. We only get to keep the value of the vector X that matches the true position in the vector Y. Another example with logical negation, just for demonstration purposes. So we can subset X in terms of Y, but now let's ask which elements are different from A using logical difference. And I'm just going to draw the output. So everything in X that comes from Y being different from A, you're going to obtain an element with 4 vectors, and that's going to be 4, 6, 8, and 10. Or as another example, let me take advantage of another binary operator. Again, subsetting X in terms of Y. Here's the operator %, % symbol. It is a binary operator. And I'm going to write a vector containing A, C, and E. And then let's close the bracket. So what I'm doing here is which elements in X actually match A, C, and D. And it's gonna be the first element, it's gonna be the third element, and it's gonna be the fifth element. So basically we exclude the second and the fourth position. These are gonna be excluded because they're gonna be associated with falses. And the output is just gonna be a vector with three things in terms of X, 2, 6, and 10.